Hey geometry students, we are closing in on the end of chapter 4. Here in lesson 6, we're going to be looking at learning target number 9, proving triangles are congruent using right triangle theorems. We've seen earlier this year, or at least this unit, where ASS actually works, and that would be the case for isosceles triangles. When you have isosceles triangles, instead of having two options, you have the one option, and then the second option actually just kind of makes a line. And so, yeah, you can prove that isosceles triangles are congruent using ASS. And we're going to take a look at another version of that here in today's lesson. All right, so we've got 4 new theorems to throw at you, and they are all right triangle proofs. Let's just get right to it. If I have 2 right triangles, so here we'll just draw 2 right triangles. Let's say that we got the right angle here. Well, we have one corresponding angle congruent. We know that we have these 90 degrees. And so what else would be sufficient? Well, the HL theorem says that if you have the hypotenuse and either of the legs, so we'll call this the other leg. So we got hypotenuse congruent, we got one of the legs congruent. Well, if you take a look at this, this is ASS, angle side side, but in this particular case, it works. Remember when we had ASS the other time, it didn't work because I had this one right here, and then I could kind of have a second angle right here, and it still works because I had 2 options. Well, if I fix this angle right here at 90 degrees, well, then that means I'm only allowed one triangle, and it has to be this one. So the HL theorem is like ASS, but it works. Okay, so if you remember back, we have 4 theorems to prove triangles are congruent when they're just regular triangles: SSS, SAS, ASA, and AAS. Okay, so these 4 worked with any triangle. Again, today the main purpose will be showing you some theorems when we have right triangles. Now, some of you might be asking, well, why do I have to do these right triangle theorems? I was just starting to figure out how to use these. I like those. Let's just stay with that. Well, the answer to that, I don't know if it's going to satisfy you or not, but we want to be as precise as possible. And using right angle theorems tells the reader the proof. So if we have 2 right triangles, we have the one set of corresponding parts for free, the right angle, but then the L and the L stand for leg, leg. So this is the hypotenuse, that's not a leg. We got one set of congruent legs congruent, and then a second set of legs congruent or sides congruent. And so you can see that this would be the exact same thing as SAS, just with right triangles. And so I want you thinking LL, same thing as SAS. All right, now with the hypotenuse angle theorem, so H still stands for hypotenuse, A stands for angle. If we go back to our 2 right triangles, we got that one angle for free. We got the hypotenuse over here. We know that's congruent. And then it really doesn't matter which angle we choose. I'll choose the top one here. Okay, you can see that either way, I would wind up with AS. Even if I pick this one over here, I would still have AS. So the hypotenuse angle theorem is simply the AAS theorem for right triangles. The final one, the LA theorem, the leg angle theorem. Again, we'll draw out 2 little right triangles. And, well, we got one of the angles and one of the sides. We can kind of pick whichever one we want. But you'll see that this one could either be the angle side, or it could be the angle side angle. If I pick this one as my side, then it would be, well, angle side angle. If I had picked that one, it would have been angle side. So this one, a little bit flexible. It's either angle side or angle side angle. So when we have right triangles, we've got to use one of these 4 right triangle theorems. Okay? But you can see that those are all equivalent to other theorems except for HL, which is ASS, but we showed that that one actually worked in this case. All right, let's get to some proofs. Your first one here says that angle T and angle V are right angles, and also that ST is congruent to VU. Prove that the triangles are congruent. So back to just proving triangles are congruent. We've got the given here. Okay. The first thing that I'm going to do in a right triangle proof is show that I have right triangles. And if I have right angles, which I do, then I have right triangles. So I'm going to say triangle STU and triangle UVS are right triangles. Okay, and that would just be by the definition of right triangle. Right? The definition of right triangles is a triangle with a right angle in it, and they've got right angles in it. So these are right triangles. All right, now I'm on a mission to find 2 things instead of the 3 from before, just kind of knowing that that's one of my 3. All right, well, we already had that ST was congruent to VU, so I got that's the one. I'm looking for one more, and well, I see that they share a side. SU is congruent to SU by reflexive. And so now I have 2 sets of corresponding things. This is not ASS because we said that they were right triangles. And so I can now just go ahead and say that triangle STU is congruent to triangle UVS. And that would be not by ASS, but by HL, hypotenuse leg. I've got the hypotenuse right here, and then one of the other legs. All right, well, that wasn't so bad. Let's try another version. We've got that TR is the perpendicular bisector of SU. All right, so TR is the perpendicular bisector of SU. That actually tells us a lot. Okay, we know that, we'll say this angle and this angle, I'll call it angle 1 and angle 2, are right angles. Angle 1 and angle 2 are right angles, and that would be by the definition of perpendicular. Because it told me they were perpendicular bisectors, I know that these are right angles. And then because I know I've got right angles, I know I have right triangles. So triangle STR and triangle UTR are right triangles. And that, again, would be by the definition of right triangle. Okay, so I had to do one extra step here to get that my triangles were right triangles. I had to go from the fact that they were perpendicular to the fact that they were right angles, and then from right angles to right triangles. All right, now that's not all I was told here. It says not only that it's perpendicular, but it's also the bisector of SU. Because it's the bisector, I know that this is congruent to this. So I'm going to say ST is congruent to UT by the definition of bisector. Okay. So I got one thing now. I need another. Well, hey, look at that. TR is going to be congruent to TR by our old friend reflexive. And I take a look at this, and I got the right triangles, and I have leg, leg. Okay, don't get that confused with the hypotenuse. The hypotenuse is over there. I don't know anything about that right now. I just have two sets of legs, and so we're going to go ahead and say that triangle STR is congruent to triangle UTR, and that's by the LL theorem. Okay, we got one more here. This one is got a little bit of a different type shape to it, but we do know a lot, so we'll just kind of draw an arrow there and say we've been given. But let's explore what we've been given for a second. We know that ML is congruent to QL. Okay, that helps. We know that triangle LPN, this one in the middle here, is an isosceles triangle, and that N and P are right angles. Okay, our mission is to prove that LMN, this one, is congruent to this one. Well, first of all, we know that we've got right triangles. We know they're both right triangles, and so let's go ahead and say that. We'll say triangle LMN and triangle LQP are right triangles. How do we know that? Well, simply because the definition of right triangle. We've been given some right angles. Okay, so now that we've got that out of the way, we just need to have two parts. We've got the one thing here, and look carefully and notice that that's the hypotenuse. Okay, so we've got H going on. What else do we have? Well, let's take a look at this other piece of information. It says that this middle triangle is isosceles. Well, that means that LN has got to be congruent to LP. That's just by the definition of isosceles triangle. Okay, the definition of isosceles triangle says that, well, you got two congruent sides, and sure enough, those are two congruent sides. And so what I'm looking at now is I've got the hypotenuse, and I've got one of the legs, and I've got the fact that they're right triangles. And so I can now go ahead and say that triangle LMN is congruent to triangle LQP, and that would be by the HL theorem. All right, that pretty much takes us to the end here of lesson 6, right triangle proofs.